Greetings students, once again welcome to another video from iCampSA. In today's lesson we're going to be doing a past paper, and the area of focus is trigonometry and trigonometric function. This particular paper is from November 2025, and it's paper 2, of course. Yes, please listen attentively and take notes as we go through the paper, because remember, mathematics is a practical subject, so you learn mathematics by actually doing mathematics. Without wasting any more time, let's get into it. Okay, the first question that has trigonometry is question number 4, and it reads as follows. 4.1: if x is equal to 67.7 degrees and y is equal to 52.3 degrees, calculate the following correct to 2 decimal places. So with these trigonometric questions, once they tell you that the answer gonna have some decimal, just know that you will have to use a calculator. But if the answer doesn't have decimals, then that's when we employ special angles. Okay, so correct to 2 decimal places. So for 4.1.1, we have to calculate sine x over 2. So this is 4.1.1, sine x over 2. And we were told that what is x? X is 67.7 degrees. So let's go ahead and actually solve for that. This is gonna be equal to sine of 67.7 degrees divided by 2. Then you punch that in your calculator, sine 67.7, and make sure that your calculator is in degrees when you are doing this. So the answer is 0.46. That is your answer to 2 decimal places. And then next we have to calculate cos 3y for 4.1.2. We are calculating what? Cos open bracket 3y. Okay, this is going to be equal to cos of what is y? Y is 52.3 degrees. So we're going to say 3, open another bracket, 52.3 degrees. Let's multiply what is within the brackets. There is 3 multiplied by 52.3 degrees, of which gives us 156.9 degrees. So we are calculating the cosine of 156.9 degrees. Okay, you put this in your calculator, you should get negative 0.91. And that makes sense because now the angle is greater than 90 degrees but less than 180 degrees, which means the angle falls into what? Into the second quadrant, and in the second quadrant only sine is positive. Remember that. Okay, and then next we have to calculate cosec x minus y over 2. So we're dealing with reciprocals. This is 4.1.3. we're calculating cosec x minus y over 2. Remember your reciprocals. Cosec is the reciprocal of what? Cosec is the reciprocal of sine. And remember, with your reciprocal for cosec, theta is the same as 1 over sine theta. Okay, so just a quick reminder of that. So this is going to be equal to 1 over sine 1 over sine this angle. Just realize that this was gonna be easier if we calculated what is within the bracket first, but it's okay. It's okay, we'll just continue with this. Okay, so let's substitute x and y. What is our x? Our x is 67.7 degrees and our y is 52.3 degrees. Okay, let's substitute that. So we're gonna have 1 over sine 67.7 degrees minus what is our y? It's 52.3 degrees, all divided by 2, close brackets. Okay, and then once we are here, we calculate what is within the brackets. Okay, let me double check. Yeah, it's 52.3. So we're gonna have 67.7 minus 52.3 divided by 2. That gives us 7.7. So we have 1 over sine of 7.7 degrees, and then this is equal to, you punch this in your calculator as it is, 1 over sine 7.7 degrees. This now gives us 7.46, yes. And that is your answer to 2 decimal places. Okay, and that is that. And then next, for 4.2, we are to solve for theta in the following equations. Correct to 1 decimal place. Okay, so for 4.2.1, what do we have is 3 plus cos for theta. 3 plus cos for theta is equal to 3.706. 4.2.1. 4.2.1, we have 3 plus cos for theta. 3 plus cos for theta is equal to 3.706, and then let's solve for theta. We were asked to leave the answer in 1 decimal place. Cos of for theta, let's take the 3 to the other side. We're gonna have 3.706 minus 3. Cos for theta is equal to, what is 3 minus 3.706 minus 3? That should give us 0.706. We have to take cosine now to the other side, so we say second function or shift, and then it should give us cos inverse. Then in this side we'll be left with cosine for theta, and here we'll have cos inverse into 0.706, close brackets, and then for theta is equal to what is cos inverse 0.706. This gives us 45.0896, and then we divide by 4 on both sides. Then theta is 11.3. Theta is equal to 11.3. Theta is equal to 11.3 degrees. Okay, and that is our final answer. Okay, and then next, let's do 4.2.2, where we have 4 tan theta is equal to 7 minus 4 tan theta. Okay, let's go ahead and do that. This is our 4.2.2. 4.2.2, we have 4 tan theta tan theta is equal to 7 minus 4 tan theta. And then in order to solve for this, they start by putting everything with tan theta on the same side. So we have 4 tan theta, take the other 4 tan theta to the other side, plus 4 tan theta is equal to 7. And remember that the trigonometric ratios can be treated as variables, so it means we can add and subtract them. So 4 tan theta plus 4 tan theta is actually 8 tan theta, which is equal to 7. Then we divide by 8 on both sides. Let me add a page for this. See, that's how I'll need a page. Yes. Okay, then we divide by 7 on both sides. Divide by 8 on both sides. This 8 will cancel that 8, and then you will be left with tan theta being equal to 7 over 8. We take tan to the other side, so we'll be left with theta is equal to, and then tan will turn into tan inverse 7 over 8. What is our theta now? Theta is therefore 7 over 8. You punch this in your calculator. Our theta is 41.2 degrees. It's 41.2 degrees to 1 decimal place. Don't forget that. To 1 decimal place. Okay. And then next we have 4.3. In which quadrant does the terminal arm of the angle theta lie? If, okay, 4.3.1, we have those conditions. Okay, I actually really do like these types of questions because they you get to apply what we have learned so far, and then you get to see these things in action, the things that we are learning here. Seeing things visually sometimes helps with understanding what you are doing. Okay, so let's go ahead and do it. 4.3.1. okay, and then to help you see, I will actually draw the Cartesian plane with our cardinal points. With not the cardinal points, with our degrees. So we're gonna have 0 degrees, 90 degrees, 180 degrees, 270 degrees here, and then 360. That's a full revolution. And remember our cast method. And remember what it means. In first quadrant, where we have A, it means all trigonometric ratios are positive. In second quadrant, it's only sine. In third quadrant, it's only tan, and in fourth quadrant, it's only cos that is positive. And then let's come here to our statement now. For 4.3.1, they are saying sine theta is less than 0. That means sine theta is negative. In which quadrant is sine theta negative? It's the third, because only tan is positive there, and the fourth, because only cos is positive. We know that in first and second quadrant, sine theta is positive. Okay, and then also another thing is that cos theta is less than 0, which means it's negative. In which quadrant is cos theta negative? In the second quadrant, because only sine is positive there, and then in the third quadrant, because only sine is positive there. And then where you have 2 stars, that's where your arm will actually lie, because both of these conditions that we've been given are met in this quadrant. So our terminal arm will be here. So in other words, for 4.3.1, in which quadrant? The answer will be what is this? Third quadrant. In third quadrant. Third quadrant. Okay, I will keep the Cartesian plane here so that you can. Okay, I want to actually copy this for the second one. It also copies the image. Now it's okay. I'll just take the copy, and then let's go to 4.3.2. This is 4.3.2. Let's bring back our angles: 91, 80, 270 degrees and 360 degrees. Remember our cast method. Cast method. Okay, and then what is the conditions? Okay, then for 4.2.3, in which quadrant does the terminal arm of the angle theta lie if tan theta is less than 0? So tan theta is negative. In which quadrant is tan theta negative? In second and in fourth quadrant, because only sine is positive in second quadrant and only cos is positive in the fourth quadrant. And then where cos is positive, cos of theta is greater than 0. So where is cos theta positive? In the fourth quadrant and in the first quadrant, because in the first quadrant all the trigonometric ratios are positive. So wherever we have 2 stars, that is where our arm will be located, and in this case is the fourth quadrant. So you write your answer is fourth quadrant. Fourth quadrant. Okay, so that is that for 4.3.1, and actually that is that for question 4. Let's go to now question 5. Question 5. So in the diagram below, P, we have that P there is the point in the Cartesian plane, such that angle SOP is equal to theta. Angle SOP is equal to theta. Okay, and remember that negative 12 is our x value, and 5 is the y value, of which stands for the opposite side. Negative 12 is the adjacent. Calculate the length of OP. What is OP here? OP, the terminal arm, is actually the what you call it, Pythagoras theorem, is the hypotenuse side. It's the hypotenuse side because x there is our adjacent side and y is the opposite side. And then length OP is the terminal arm, or the R. So OP is the hypotenuse side. So we have to use the Pythagoras theorem to solve this. So we're gonna say OP, the length we are looking at, squared, is equal to x squared plus y squared. And then let's substitute accordingly. We have negative 12 and 5. Negative 12 squared plus 5 squared. We're looking for OP. Therefore, OP squared, what is negative 12 squared, is 144 plus 5 squared, which is 25, and this is 169. Therefore, OP squared is equal to 169. We introduce the square roots on both sides. Therefore, OP, what is the square root of 169? As far as I know, it should be 13, but let's double check. It should be 13. Yes, that is the square root of 169. Square roots of 169. Okay, and there you have it. And at this point, we have to go to 5.1.2. 5.1.2. Let's read the statement. And hence, without the use of a calculator, determine the value of what? Of tan theta. That is our A, tan theta, the value of tan theta. And be careful with this question. You are not asked to determine the value of theta, but the value of tan theta. And remember, what is tan theta equal to? remember your SOHCAHTOA. Tan theta is the ratio of tan theta is opposite side over the adjacent side. Opposite over the adjacent. So tan theta is equal to, let me quickly write that, opposite side over the adjacent side. And I said the opposite side, what is the opposite side in our Cartesian plane? Is that y, the value of y. So it's gonna be 5 over negative 12, because 12 is the adjacent side. So we're gonna have 5 over negative 12, of which would give us this is equal to negative 5 over 12. Negative 5 over 12. And it's negative because only sine is positive in the second quadrant. Okay, and then secondly, we have to calculate without using a calculator the value of sine theta plus cos theta squared. Okay, that is our B. This was A. And then for B, we have to calculate the value of sine theta plus cos theta squared plus cos theta squared. What is sine theta? Sine theta is opposite over the hypotenuse. Let's start by writing that, reminding ourselves. Plus cos theta is what? Is adjacent over hypotenuse squared. What is the adjacent side? The adjacent side is the one with 12, negative 12. So we're gonna have negative 12 over the hypotenuse side that we calculated there was 13 plus, sorry, this is the opposite side actually. Opposite side is 5 plus adjacent side, which is negative 12 over 13, everything squared. Okay, and then we're gonna have, let's add, keep the same pace, 5 minus 13, 5 minus 13, that should be 8. Sorry, 5 minus 12, 5, it should be 7. 5 minus 12, it should be negative 7 squared. Okay, let's square this. What is the square of 7? It's gonna be 49, positive 49, and then the square of 13 is 169. 49 divided by 169. Okay, and there you have it. That is your final answer. That is your final answer. Okay, so that is how you go about answering 5.1.2. okay, let's go to 5.5.2. Okay, for 5.2, we're told that in the diagram below, angle WMT is 90 degrees. WMT, or this angle. And then we are told that this angle 70 is, sorry, this angle W is 70 degrees. From the word go, since we are dealing with triangles, what do you do when you realize you have 90 degrees angle, you have 70 degrees angle? Let's quickly calculate the angle T. The angle T. Okay. The angle T. Sum of angles in a triangle. So you're gonna say 90 plus 70 is 160, and then 180 minus 160. The angle T is 20 degrees. 20 degrees, and the way we calculated it is sum of angles in a triangle. Okay, we have that. Once we are there, let's see, and then MW is 40 units. MW is 40 units. Okay, that is all we are given basically. Determine the length of WS. Okay, of WS. Okay, look what we have here. We have this hypotenuse side, because this is also a triangle. That angle S1 is gonna be 90 degrees. Angles on a straight line is 90 degrees, which makes triangle WSM A, angle WS, sorry, triangle WSM, a what? A right angle triangle. So we are allowed to use trigonometric ratios to solve for this triangle. So we are given what? We are given, we have the hypotenuse side WM. WM is 40 units. 40 units is the hypotenuse side, and we are looking for WS, and we have the angle 70 degrees there. We're looking for WS. What is WS? Is the adjacent side. This is the angle next to W. It is the side next to the angle 70, so it's the adjacent side. So which trigonometric ratio should use in order to solve for this equation? We have to use the one that includes the adjacent side and the hypotenuse side. So Katoa, that should be our cosine. So cos of 70 degrees is equal to adjacent side over the hypotenuse side. What is our adjacent side? Is WS over the hypotenuse side, which is WM. Okay, and then let's make WS the subject, is what we are looking for. WM, what is the value of WM? Is 40 units, so we're going to have 40 units multiplied by cos 70 degrees. Okay, therefore our WS should be, you punch that in your calculator, cos 70, it gives us 13.68 units. It's 13.68 units. 68 units. That is the length of WS, 13.68 units. Okay, and then next, and hence otherwise, determine the length of ST. The length of ST. Okay, so we have the length of 40 units, and then now we are looking for the length of ST. The length of ST. Okay, so in order to calculate the length of ST, we can calculate the side of SM. Since we have 40 units, we can use the sine to calculate the side of SM, and then once we have that side and we have the angle that we calculated there of 20 degrees, we can solve for ST. Okay, but first thing first, let's calculate the side of SM. 5.2.2. 5.2.2. First thing first, SM. So SM is opposite to the 70 degrees angle, so we're gonna use the sine. Sine of 70 degrees is equal to SM, opposite over hypotenuse. What's the hypotenuse? Is 40 units. 40, therefore SM is equal to 40 sine 70 degrees, of which would make SM to be 40 sine 70 degrees, 37.59 degrees. Okay, that is our SM. This is the SM, which is 37.59. Okay, and then let's declare what we have there. Angle T. We just say angle T is equal to 20 degrees. The reason we have already stated angles on a triangle, before we can use this, and then once we have declared that, we can now use it. We have 20 degrees there, and then we have what? We have the side 37.59 units, side SM, and we are looking for ST, the adjacent side. So we have the side opposite to 20 degrees, the opposite side, and we have the side adjacent to ST, which means we are gonna use what? We're gonna use the tan, because tan trigonometric ratio, because it is the tan trigonometric ratio that includes opposite side and the adjacent side. So tan of 20 degrees is equal to, what is the side opposite? Is the one for 37.59. 37, it's not degrees here, it's unit. So it's 37.59 over, what is the other side, or is the one we're actually looking for? ST over ST. Okay, then we make ST the subject. ST is gonna be equal to 37.59 units divided by tan 20 degrees, and therefore ST is equal to punch that in a calculator, should give you 103.27 units. Okay, and that is how you solve for that 5.2.2. 5.2.2. Yes. Okay, let's come back for a while here. You could have also calculated ST by actually calculating the entire length of WT, because in this triangle, you see this big triangle, of which is also a right angle triangle. That triangle, this side WT is what? Is a hypotenuse side, and we have the angle here of 70 degrees, and we have the side of what? 40 units. So you could have just calculated the length of this entire side and then subtract the length of WS to solve for ST. You could have actually done that, but either way, both answers should be the same. Okay, and then next we have question 6. Okay, then for question 6, we are given g at x is equal to cos x plus 1 and f at x is equal to 2 sine x. For x is the element of 0 degrees to 360 degrees. So we're given two function. It's a cosine function plus 1. What does that plus 1 mean? It means it has been shifted 1 unit upwards, and then we're given the sine function, of which is 2 sine x. That 2 sine x, it means the function has been stretched. It's a vertical stretch, and also it means that the amplitude for the sine function is what? Is 2, just in case we are asked those. So for 6.1, what are we asked to do? On the grid provided, okay, we don't have a grid, we're gonna construct our own. Sketch the graphs of f and g on the same set of axes. For x is the element of 0 to 360 degrees. So first thing first, we have to sketch the graphs. So for 6.1, easiest way, let's just do the table. So that we can have coordinates that we'll use to sketch our graph. So we're gonna say x, we use 0. Okay, let me construct a table first. Hopefully this table would be enough. And then we're gonna use what? 0. Let's use the intervals of 90 degrees. So we're gonna have 0, 90, 0, 90, 180, 270, and 360. Okay, just an extra there. So we're gonna have 0 degrees there, 0 degrees, 90 degrees, 180 degrees, 270 degrees, and 360 degrees. Okay, those are the degrees those are the values we're gonna use. There, I wanted to clean this one up a bit. So we're gonna just I wanted to actually increase this. That will be your 0, 90, 180, 270 and 60. Yeah, just to 0 degrees, 90, 180 degrees, 270 and 360 degrees. Okay, so once we have that, we're just gonna use y for both of them. This was our x here, the one in degrees. The corresponding y values, we're gonna say for the g of x is cos x plus 1, and then the other one is 2 sine x. Okay, let's find the corresponding values for this. So cos of 0 plus 1 gives us 2. Cos of 90 plus 1, it gives us 1. Cos of 180 plus 1, it gives us 0. Cos of 270 plus 1, it gives us 1. And then cos of 360, because 360 plus 1 gives us 2. It gives us 2. Okay, and then let's find corresponding y values for the function of f of x. So it's 2 sine 0, we get 0, and then 2 sine 90 is 2, 2 sine 180 is 0, 2 sine 270 is negative 2, and then 2 sine 360 is 0. Okay, yeah, we have those points. They should be enough for us to actually sketch these functions. Next step, let's construct our grid or Cartesian plane. Okay, and this side is the x side, and here is the y side. Okay, we're gonna have let's just use 1, 2, 1, 2, and then we're gonna have 0, 90, 180, 270 and 360. It's 90 degrees, 180, 270 and 360 degrees, and then we have 1, 2, negative 1, negative 2. Okay, let's plot the points for the first function, where x is 0 degrees, y is 2, then where x is 90 degrees, y is 1, where x is 180, we have 0, 270 is 1, and 360 is 2. Okay, and then we join our points. It's a curve, remember, it's a curve, and that is how our function is gonna look. Let's quickly, this one is the one for g at x. G at x is equal to cos x plus 1. Let's construct the other one for 2 sine x, where x is 0 degrees, y is also 0, where x is 90 degrees, y is 2, where x is 180, 0, 270 is negative 2 here, 360 is 0. Okay, that's the second one. And then let's construct our curves. Let's construct our case. Okay, and that is how the second function is gonna look. This one is the one for f at x is equal to 2 sine x. F at x is equal to 2 sine x. Okay, and there you have it. And there you have it. The requested drafts or sketches for the functions. And then next, for the number 6.2, write down the period of f, the cosine, the sine function, not the cosine, the sine function. So remember that with cosine and sine functions in grade 10, the period 99% of the time is gonna be 360 degrees. So period, remember the period is the time it takes for the function to complete one cycle. So it's 360 degrees. Let's come here. We're looking at the sine function, goes from 0 degrees all the way until it comes back here at 360 degrees. Once it reaches 360 degrees, one full cycle has been confirmed and it's been completed. If we were to do more degrees up until maybe 720 or something, you will see that it will take another 360 degrees to complete another full cycle. So that is the period. And then next, for 6.3, the range of g, the range of g, this g function. So you can see that the minimum value is what? Is 0 here, and the maximum value is 2. So the function only exists between those two values. This is our 6.3, saying the range of g, y is the element from what? From 0, square bracket, because 0 is included, to 2. That is the range of g. Okay, and then for 6.4, for which value of x will g at x minus f at x divided by 3 equal to 1? So equal to 1. A simple trick here, we have to find values, the value of x, whereby g at x minus f at x will equal to 3, because 3 divided by 3 is what will give us 1. So you are looking for the values of x where g at x minus f at x will give us what? Will give us 3, because 3 divided by 3 will be equal to what? Will be equal to 1. Let's come to our function here. We are looking for the values of x where g at x minus f at x will equal to 3. That is 6.4. That is 6.4. We're saying g at x minus f at x divided by 3 is equal to 1. So I'm saying we are just looking for the values of x, for the value of x where g at x minus f at x will be equal to what? Will be equal to 3. Now let's come here to our functions. Here, when I'm looking for where x is equal to 0 degrees here, let's look. G at x is 2 and f at x is what? Is 0. So 2 minus 0 is 2. 2 over 3 is not equal to 1. But let's come here to 270. That's one I am just seeing. 270, g at x is what? Is 1, while f at x is what? Is negative 2. So 1 minus minus 2 is going to be what? 1 minus minus 2 is 1 plus 2 is 3. So 3 divided by 3 will be 1. So therefore it's where x is equal to 270 degrees. That is where what we are given here will be true. That is where g at x minus f at x divided by 3 will be equal to 1. will be equal to 1, where x is equal to 270 degrees. Okay, and that is, folks, the final answer for question 6. Okay, yeah, I think it's the last question for this paper that concerns trigonometry and trigonometric functions. Yeah, I hope you learned something from this video and this lesson. Until we meet again, I wish you guys good luck and good study.